Hi everyone, welcome back. In this video we're going to take a look at domain and range and how we can find domain and range from a table and from a graph. Alright, so we're looking at domain and range. The first thing we're going to do is define domain and range. The domain of a function is the set of all numbers in the input. So all the numbers that we can input into the function, all of those numbers are what we call the domain. The range is very similar. We have a set of numbers, set of all numbers in the output. Output of our function. So domain is all the numbers that we can put into the function. The range is all the numbers that can come out of the function. Usually we'll be talking about a function when we're working with domain and range. Sometimes we'll be given something like a circle on a graph that's not a function, but we can still talk about domain and range for that. In that case, something that's not a function that we can still graph is called a relation. It shows a relationship between x and y. So that's just the word we use if we don't have a function specifically. Okay, so let's take a look at some examples. First, let's look at a table. So let's say we have a table. We have an input variable x and an output variable y, and we can even label these as specific examples. So we could be modeling a situation with a table. For example, x could be the day number, and y could be the amount of money that you made that day. So maybe you're running a business and you're looking at each day since the beginning of the month, and then how much money you made. So 1, 2, 3, 4. And then maybe you made $20 on the first day, 40 on the second, 35 on the third, and then the fourth day, you only made $5. Like a short day, maybe. Okay, so we have a table, we have x and y values. When we're given a table, the domain and the range is just, we can just list those as a list of all of the numbers that we see for the x's and all of the numbers we see for the y's. So here, our domain is just going to be all of the numbers that we have under the x column. And when we list out a set of numbers, we can use these curly brackets to indicate that we're talking about a collection or a set of numbers, which just means we have a group of numbers that we're putting together, and the curly brackets is saying we're listing out the numbers inside of here. So we have 1, 2, 3, and 4, and then we'll close our curly brackets. So that's our domain. Our range, similarly, is listing out the set of numbers that we see for y. So over here, we have our y numbers. And for now, the order doesn't matter. So sometimes I'll list them out in from least to greatest, like maybe I'll start with 5, then 20, 35, 40. But if you have a different order, that's okay too. All right, so that's it. That's our domain, and that is our range. One small note is if we have in the range, let's say day 5, we also made $20. If we have a number that repeats in the range, we have a 20 for day 1, we have a 20 for day 5, we're only going to list 20 once because we already said that 20 is included. It's one of the numbers in the range, so we don't need to write it again. If this was our new situation, we would make a quick change. We would add on 5 to our domain because we now have day 5. For the range, though, the range doesn't change because the 20 is already included in the range, so that hasn't changed. Okay, so that's an example of looking at a table and identifying the domain and the range. Next, I want to take a quick look at some graphs. So to find the domain and range on a graph, what we want to look at is the set of numbers from left to right and the set of numbers up and down that our graph covers or goes over. So for example, maybe we have a graph that's a line, and then I'm going to list a few points. So here our line ends at an x value of 3, a y value of 6. Down here we have an x value of -2, or sorry, y value -2, and down y, and then an x value of -1. Okay, so when we identify the domain, we're not going to be listing out every single number because there are an infinite number of numbers actually in this range. So we can't actually list out or write down every single number. So instead we're going to write an interval. And intervals are just taking our variable we're looking at, which is x in this case, and then using inequalities to describe where x is on our graph. So here we're looking at domain, which is going to be left and right. Our input variable is the x-axis, so left and right. So as you can see, the smallest number we reach is -1, and the largest number we reach is 3. So for our interval here, we have x. X is going to be greater than or equal to -1. And then on the right, I'm saying x is less than or equal to 3. So -1 less than or equal to x, which is less than or equal to 3. So that's our interval. In other words, the set of x values that we could input into this graph. You could also write this as x is greater than or equal to -1 and x is less than or equal to 3. Either one works. This is just called a compound inequality, where I wrote them all in one kind of like line or statement. Okay, for finding the range, we're going to do something similar. We'll look up and down. So looking up and down on our graph, we can see that our smallest y value is -2, and our largest y value up here is 6. So x is greater than or equal to -2. Actually, I made a quick mistake here. Because we're talking about range, we want to use y instead of x. This is a common mistake, so definitely just double check when you look at domain and range. Make sure you're using x or y, depending on which one we're looking at, and less than or equal to 6. Okay, so there's our domain and our range for this graph of this yellow line. I have one more thing to go over for domain and range, and then we'll be finished. The last topic I want to talk about is open versus closed circles. So sometimes on a graph, you'll notice that we have an open circle instead of a closed circle. And let me draw a quick example. So maybe we have a line. Actually, let's go ahead and do a curve like this. Okay. So here, let's say we have 5. And I'll actually do this in blue. 5. Here we have 4 for x. Over here we have -2 for x. Down here, our minimum y value is going to be at -3. And then our maximum up here, we could just say is +3. Okay, so we have a curve, and we're trying to describe the domain and the range. Let's take a look at the domain. So for the domain, we can see that the -2 is our smallest value. And our graph reaches, we can see our graph actually reaches -2 and then starts going in the other direction. So -2 is going to be our smallest. And then our largest value is 5. And this closed circle means that the graph reaches an x value of 5. So 5 is included in the domain of our graph. So this means we're going to include 5. So we'll say x is less than or equal to, because x could be equal to 5. And we'll also include -2 because we reach -2 on the left. Okay, so there's our domain. And then for our range is going to be a little bit different because of the open circle up here. So looking up and down, we can see that our smallest y value is -3. Because we have a closed circle here, our graph actually reaches a y value of -3. So -3 will include less than or equal to, because y actually reaches -3. But the open circle at the top, so notice 3 is our maximum y value. The open circle is saying that our graph doesn't include this point. So this endpoint is not included in the domain and the range of the graph. So the graph gets really close to that point, but doesn't quite reach it. That means that y cannot be equal to 3. We don't actually reach a value of 3. When describing the range, in this case, what this means is if we have an open circle, instead of doing less than or equal to or greater than or equal to, we'll just do strictly less than or strictly greater than. So y is less than 3. And we are not including or equals to because y doesn't actually reach a value of 3 on this graph. So notice I only looked at the minimum and the maximum values. So although one of the endpoints is right here on our graph, when I was looking left and right, that point wasn't one of our minimum or maximum values, so I kind of ignored it when looking at our domain and range. One last point, this is not a function, you might have noticed, because it does not pass the vertical line test. But that's okay, we can still describe domain and range of relations, so graphs that are not functions. Okay, so those are some examples of how we can find domain and range using a table and a graph, and also the meaning of an open point versus a closed point on a graph.